Hello, welcome to channel Maths Magic. Today we are going to discuss new topic. It's a geometric sequences. You have already learned that if you have any specific pattern, we call it sequences. Out of these sequences, we have already covered arithmetic sequences. Now we have to discuss geometric sequences. So how can we identify if any given pattern is a geometric sequence? So it's a very simple to identify it. I'll give you example, then I'll explain you the basic definition. Let's say we have a sequence 2, 4, 8, 16, 32, so on. So you just look at this pattern and observe how this new pattern is occurring. So you can see that to get the new number or to get the next term, you have to multiply with 2 from the previous term. So if you get multiplying 2 constantly to the previous term, you'll get the next term. This is the pattern over here. So if you have any such pattern where you have to multiply with any constant term, you can say with any constant number to get the new term, then we can say that this pattern is basically geometric sequence. So in nutshell, you can say the geometric sequence are those which can be obtained by multiplying with constant number. Now we have to see some more examples. So let's say if you are having any pattern like this, 3, then 6, then 12, 24, 48, so on. So you can see again over here new term is obtained by multiplying with 2 to the previous term. So over here again it's a geometric sequence. Now let's see one more example. So let's say we are having 5, 15, 45, 135 and so on. So you can see that we get the new term by multiplying 3 to the previous term. So again this given pattern is geometric sequence. So it's very simple to identify that if any given sequence is a geometric or not, but I'll give you the proper technique to identify if any given pattern is geometric or not. So what will you do? You have to find the ratio of two consecutive terms. You have to find the ratio of two consecutive terms. So over here you have to find the ratio of 4 upon 2, then 8 upon 4, then 16 upon 8, 32 upon 16. So you have to find the ratio of next term upon previous term, next term upon previous term. So if these ratios are equal, then you can say that it's a geometric. So over here you can say 4 upon 2 gives you 2, 8 upon 4 gives you 2, 16 upon 8 gives you 2, 32 upon 16 gives you 2. Therefore this sequence is having constant ratio. So you can say that if any sequence is having constant ratio, then it's a geometric. So easier way to identify if any given sequence is a geometric or not, you have to simply find the ratio of consecutive terms. So in these consecutive terms you have to take next term upon previous term. If these ratios are equal, it's a geometric. So we can check with this sequence also. So you have 15 upon 5, 45 upon 15, and then 135 upon 45. In all these cases, you can see that ratio always equal. Therefore, it's a geometric sequence. I gave you the easiest way to identify if any given pattern is geometric or not. Now we'll see some formulas and nth term which will help you to find out answer for any given question. So first of all, you need to be familiar with some terminologies over here. In geometric sequences, you have to use the formula for the nth term as un is equal to u1 times r to the power n minus 1. So over here, as you know, un is your general term or nth term, and u1 is first term. u1 is first term and r is called common ratio. Common ratio. This common ratio is basically obtained by taking ratio of two consecutive terms, and while you will find the ratio of consecutive terms, you have to always take next term divided by previous term. So you have to keep this in mind that it's always next term divided by the previous term. It will give you the common ratio. Now let's see how can we use this formula. Let's say we have this sequence and you want to find out the fourth term of the sequence. So let's write important information for this. You are having u1 as 2 and r, as I told you, it's a ratio of two consecutive terms, so it's a 4 upon 2, which is 2 again. Now we are looking for fourth term, that is n is 4. Let's use the formula. un is equal to u1 r to the power n minus 1. So we are looking for n as 4, so u4, then u1 is 2, r is 2 again, and then 4 minus 1. Let's simplify this. It's 2 into 2 to the power 3. So 2 to the power 3 is 8 times 2 is 16, and you can see we have 60 on fourth place over here. This is how you can find the any specific term of geometric sequence using this nth term formula. Okay, now sometimes what will happen that they will give you two consecutive, any two terms may be consecutive or may not be consecutive, and then you have to find u1 and common ratio and any specific term or nth term or general formula for that specific sequence. So you can use these you can use these formulas and these techniques to find the answer, and that will be really easy for you. Hope it's clear. If you still have any doubts, let me know. I'll get back to you for sure. Thank you for watching.